Good morning and welcome to all of the people who are watching us and spending time as we go through the Essentials 40S class lesson for today. So, today, what I plan on doing is to go over some of the extra practice sine and cosine law questions. Um, so, if you actually go on the blog right now, you can find the full solution of this. And so today I just wanted to make sure I explain it just in case some people have questions on some of these. So in this particular case, this is a mix of sine and cosine law questions. So the key thing here is understanding which formula to use, when to use it, and then also how to use it. So let's take a look. I'm going to focus on, like I said, some questions, not necessarily. I'll do as much as I can for this one for the time that we have. So let's start with number 1A. Okay. So I'll get my pencil. When we look at this one in here, what can we do? So last time when we talk about the very last lesson in trigonometry, we looked at when to use what formula. So we said here, this is sine law formula. We will know how to use this if we have use, if we have complete pair. Complete pair of side and angle. Okay, so that's for this formula, the sine law formula. It's not, hope that's pretty clear. Now for this one, this is a cosine formula, and we're going to use this formula if we have a sandwich. Given angle between two given sides. And I call it sandwich because, you have some kind of a mental picture or see what's going on. So sometimes the triangles are not labeled. Sometimes the triangles are not A, B, and C. So here's the thing that I mentioned before is that if you have side A here, side A, and then we're going to end up with A, angle A at the end. Okay, so if you're looking for side A, then it would be the two sides, two given sides, minus 2 times the two given sides again, but it's not squared, and then cos of the angle. That's the sandwiched angle. Okay, now the last formula here, this is also a cosine law formula, but it's basically just kind of rearranged so that we are calculating the angle. And then when do we use this? So use if we have three sides given. And because we have three sides given, if we have three sides given, we're going to look for the angle or one of the angle. So if you look at this one again, sometimes they're not labeled A, B, and C. They're labeled X, Y, and Z. So if you just take a look, so whatever this angle is, so angle A, and then this one here is side A. Okay. So, the only thing that's not in here is rule 180. So rule 180 degrees, and we know that already, rule 180 degrees. So the sum of all the angles in a triangle adds up to 180. So now we've come to this particular question, and you look at this triangle. What is the strategy that I'm going to be using for this one? What is a strategy? So when you look at this strategy, um, let's see, we can check if there's a complete pairing. So is there a complete pairing of side and angle? Okay, now I see here. Here's my angle, and then look at the pair. This is the side that goes along with it. Okay, so we got the angle and side pairing right there. So, oh, okay, so that's the pair. And then this one here, somewhat complete pair. So you got this angle, and then we're looking for a side. So in this particular case, because we have a complete pairing, and then we have that partially complete pairing, then we're going to use sine law. So that's how I think about it. Okay, so what does the sine law look like? So we start with the side divided by the sine of the matching angle or the pair angle, so 35 degrees. Okay, so we got the side divided by the angle, sine of the angles. Make sure it's sine angle. Now here, this is a somewhat complete, okay? Only one thing is missing. So start with the side and then divide by the sine of the angle, sine of 65. And then, so for the test question or any questions that you do, it's important that we set up. So this is a setup. And then we got to, do the in between the work and then our answer at the end. So in this particular case, we're trying to solve for x. So that means we have to get rid of the sine dividing by sine of 65. So we can just cross multiply that, cross multiply. So that makes 15 times sine 65. And then this one is still divided by sine 35 at the bottom in the denominator. And then we're left with x. And left with x. Okay, so the x is by itself. X is by itself. Now we just need to use our calculator. We're ready for it to type this in and then figure out our answer. Okay, so I have to always check before I get started to check if my calculator says degree, because we want to make sure it says degree. So mine is okay. So I can go 15 times sine 65 divided by sine 35. So 23.70 degrees. No, not degrees. Whatever unit is, centimeters. Okay. So that's that. So that one is not so bad. Okay. This one, I'm actually just going to leave that with you. If you want to see the full solution for this one, see the blog and the solution is there. I'm going to go and take a look at this one in here. Okay, so taking a look at letter C. Now, letter C is, okay, so what can I do in here? I'm trying to solve for this one, okay? Now, the first thing I check is, can I use sine law? Okay, I see that this is a complete pairing. Yeah, so that's okay. So that's a complete pairing. So I might be able to use sine law, but when I look at this one, I have nothing in here, no angle and no side. So that is not going to work to be able to solve for something to be able to use sine law to solve for a side or an angle, we need to have at least half the pairing. Okay, so we can only have one unknown information. This one, too much unknown. You don't have the angle and we don't have the side. So what can we do? Well, this angle is right here, but this is not the side that we're supposed to calculate. We're supposed to calculate that one. So what can I do? What can I do? Okay, well, I see that there are two angles in here. Because I have these two angles in here, I could figure this angle out. Okay, so I can calculate that angle. So I can call it angle A, angle theta, doesn't matter. Okay. So we're going to call it angle A. We'll just call it angle A. So angle A is equals to 180 minus 105 minus 35. So therefore angle A is how much? 180 minus 105 minus 35, and we got a 40 degrees. 40 degrees. Okay, great. So now we have that angle right there. Okay, we're ready to use our our sine law to solve for this side. Ready to use sine law. So let's do that. So sine law, you start with the side, so 40 divided by the sine of the angle, okay, sine of 105, the paired angle is equal to, start with the side, divide by the sine of the angle, sine of 40 degrees. So that's that. Okay, so again, this kind of now looks like the letter A, question 1A. We're solving for x, so we're going to cross to multiply. So we got 40 times the sine of 40. So 40 times the sine of 40 divided by, because this is still in the denominator, so sine divided by 105 equals to x. Okay, so I will be watching for the strategy. So x is equals to all of that. So I think we're ready. Can go 40 times sine of 40 divided by the sine of 105. And I got 26.61, but then I see the 8 right there, so it would be rounded up to 2, to 26.62. And what am I looking for? So x is the side, so the side length are measured in meters, so meters. Right there. Okay, so I wanted to go over this with you because this one has a two-step. Okay, so this is a two-step kind of question. Okay, so moving along. So if you didn't catch this, you of course the full solution key is on the blog already. So I will still scan this and then have that the other one as well. Okay, so this one, what can I do with this one? Okay, what information? Now, from any situation in here, I won't have any complete ratio, right? Complete pairing, because I got all three sides. Okay, all three sides. What strategy can I use for that one? Okay, well, what strategy can I use for that one? So if I slide up here, we're going to use this version of cosine law. It says here, use if we have three sides given. which is exactly what this is. Now, we know that it's going to be a cosine. It's just now a matter of figuring out what number goes where, right? So we know it's a cosine. So this is my angle, okay, cosine of theta, okay. Now if I have this angle here, I gotta end up with the the side that goes with that. Okay, so let me flip it back again over here. So if this is my angle A, I have to end at the end with side A. Okay, so angle A, and then here at the end is side A. So if this is my angle A, then that's my side A. So I have to end there. And then these two are the two that I have to be starting with. So I can go 5 squared plus 6 squared minus 7 squared. Okay, so if these are all mixed up, then we might be actually solving for a different angle. So make sure that we write it down properly. So this is the angle theta, and then this is the side that goes along with it. So if you want to call this angle A, then this would be our side A. So last time I said that okay, we can put everything all in a calculator, but we have to make sure we put a brackets on each end of the numerator and each end of the denominator so that we can do all of that all at once. So cos theta is equals to, now it's a matter of typing that in. So I'll do that. Oh, that's nice. It's 0.2. Okay, so now if this is a long string of number, don't round off right yet. So keep that the way it is. What we're trying to solve for is theta, the angle. So somehow we have to get rid of the cos. So how can we get rid of the cos? So what we need to do is we need to do the cos inverse, cos inverse. So if I take the cos inverse and cos, they cancel each other out. So I'm left with theta. Okay, so make sure you don't put cos theta anymore. It's just theta. And then here, cos inverse of 0.2. So we can do that. We can calculate that. So cos inverse of 0.2. I'll just put answer because that's what my answer before. And I get 78.46. What's that mean? So 78.46 degrees. Okay, so that's it. Okay, so that's page 1. So I'm just gonna go to page 2. For page 2, I'm actually going to do question letter E. Question letter E, because we haven't seen that one yet. Okay. So question E, what can I see here? Do I have a complete pairing? Do I have a complete match of side and angle? Okay, I see this is my angle, and then it opens up to that side. Okay, so there's the match right there. And then this one, oh, okay, I have the 40 inches here, and I'm looking for this angle. So this one is almost complete. Okay, only one information is missing. So that one is sine law. Okay, sine law because I have a complete pairing. And then I can only solve for the one that's half complete. It only means one missing. So sine law, start off with the side. So 55 divided by the sine of 100 equals, I gotta start with the side, so 40 inches divided by sine theta. Sine theta. Okay. So in this particular case, the information that's unknown is in the denominator. So what I gotta do is get that out of the denominator by cross multiplying. So this one, I have to cross multiply everything for both sides. So what does that look like? So that becomes 55 times sine theta equals 40 times sine 100. Okay, so that's what it looks like. Okay, so now the next thing that I gotta do is to get rid of this 55. So I have to divide by 55, divide by 55. And the reason why I'm dividing it by 55 is to cancel the 55 out of that side of the equation. Can you see 55 is multiplied by sine theta? So what's the opposite of multiply? You gotta divide. So that's gone. So sine theta is now equal to all of that. Well, all of that is going to be what? Okay, I can figure that out. 40 sine 100 divided by 55. And that's going to give me a number. It's 0.716222382. Okay, so don't round off here. Okay, keep as many decimals as possible. Now, the last step is to solve for theta. Okay, well, how do I get the theta alone? Can you see it's sine in here? So if I take the sine inverse, that will cancel the sine. So I gotta take the sine inverse on both sides. Okay, so sine inverse will cancel the sine, so they cancel each other out. I'm left with theta, which is the sine inverse of that. Sine inverse of that is 45.74 degrees. Okay, so there you go. That's really, really, really good. Okay, so I'm gonna go. I went over question 1E. You could try this on your own. Okay, and if you have questions, you could always go to the blog and check this full solution of that one. I have the full solution of this one. Okay, so I won't go over that one. And then you can work on this one. Okay, so this one is actually similar to question letter E. So H and E are very similar. Okay, now I'm gonna go over question number 2, letter A. It says here, sketch each triangle and solve. And then solving the triangle means finding all the missing parts and angles. Okay, so here there's no picture. They just can kind of say, oh, this is angle T is 130 degrees. Angle R is 40, side T is 31. Okay, and then we also have to figure out all the rest. So angle T, our triangle will have vertices TRS. So just draw a triangle TRS. Okay. Can you see angle T is a really big and wide angle, so that we can call this angle T. So that's our 130 degrees. It doesn't have to be exactly 130 degrees, so you can just kind of sketch it. So if this is angle T, then that means right across from that is side T. Okay. So they said side T is equal to 31, so this is 31. Now angle R, well, we already have the T down, so we can just pick a different corner. So we can call this R here. R is 40 degrees. And then that makes this one angle S, which we don't know what angle S is. Okay, so those are the only three information that we got from this line up here. So this is a triangle TRS. So TRS, angle T is 130, angle R, so just pick another angle that's 40, and then angle S, we don't know what that angle is. We can figure that out. Okay, so what are we trying to figure out in here? We have to solve for angle S. We also have to solve for side R, and we also have to solve for side S. Okay, so which one can we do first? Okay, what does it? Let's see if we could. I think angle S would be the easiest one to solve because angle S, we can use rule of 180. We got two angles given. We can figure out angle S. So angle S is equals to 180 minus 130 minus 40. So angle S is equals to 10 degrees. Okay, 10 degrees. So that one's done. That one's easy. 10 degrees. I'm going to put 10 degrees there. So I'm going to put 10 degrees there. Figure that out. Now, what else can we do? Okay, well, I see there's a complete ratio here. You get the angle of 130 and then side for 31. And then I can look at this too. Okay, I got the angle there. I'm just missing one information. So I can use the sine law to figure that out. Okay, so sine law to figure that out. How do I do that? Start with the complete ratio. 31 side divided by the sine of 130 is equals to side, so R divided by the sine of 40. Okay, so now nice and set up. I'm trying to solve for R. Okay, so what can we do? What can we do to have the R all alone, isolated on one side of the equation? I can just take this and cross multiply over there. I don't have to do cross multiply everything. I can easily have the R by itself by cross multiplying there. Okay, so let's do that. So 31 times sine 40 divided by sine of 130 equals to R, because now the R is alone because this has been crossed to multiply with the 31. So R is now alone. This one I can calculate. 31 times sine 40 divided by sine of 130, and I get 26.01. And we're looking for a side here. They didn't really tell us what unit it is, so we'll just put 26.01 unit, whatever unit that is. You can just leave it alone like that. Okay. Okay, so that's it. 26.01. So we got angle S, we got side R. Now I gotta figure out side S. Side S. $26.01. There. Side S. Well, for side S, what we could use the sine law again. Okay, we can use sine law because we have a complete ratio here, and then this one here, side S, we have half complete ratio, so we could use that one. Okay, we could also use another possibility is that, okay, these two sides are given and then this angle in between is given, so we could also use a cosine law to do that. Okay, so for side S, We can use sine law or cosine law. Okay. I think I'm gonna use cosine law in this one. I think um, I used sine law last time, so I'm gonna use a cosine law to solve for side S. Okay, because we have the side, we know this side, and we know this side, and we know this angle. We got a sandwich, so we can solve for that side. So S squared is equals to these two sides, 26.01 squared. You don't have to put it inside the brackets. 31 squared minus 2 times 26.01 times 31 times cosine of 10 degrees. Okay, so that's the cosine law right there. Now it's just a matter of typing all of those information out. Okay, so let's go ahead and try that. Okay, so I'm going to end up with a 49.39942,134. Okay, don't round off too soon because that's not our answer yet. This is S squared. To get rid of the squaring, we have to take the square root. So finally take the square root on both sides. So so I'm going to take the square root of my answer. So I got 7.03 unit, whatever unit that is. They didn't tell us. Okay, so there you go. We've solved here. We're given some information, and then we use either Rule 180, sine law, and then we did a cosine law here to solve for all of the missing information. 7.03. Okay, good. So that's that. So I'm going to get that scanned too. Okay. So here's what we're going to do. Okay. The next thing that we're going to do, I'm going to go over question number 3, 4. These are all the problem solving now. Okay, so we'll do question number 3. Getting to the problem solving question. It says, suppose that you are the pilot of a commercial airliner. You find it necessary to detour around a group of thunder showers, clouds. Okay, you turn at an angle of 21 degrees to your original flight path. Fly for a while, then turn and reach your original path at an angle of 35 degrees, 70 kilometers from where you left original path. How many more kilometers did you have to travel from original 70 kilometers because of the detour? So if we were to go that way, this is the plane going, right? This is the plane. Right? That's a plane. It's supposed to go from should be right there, from here to there at the 70 kilometer stretch. That's not too far. Now, because there's a big cloud here, thunder clouds, instead of going straight, it went and then heading on to the original path. So that's basically what the story about for this one. So turning at an angle of 21 degrees, and then fly for a while, and then turn to reach your original path at an angle of 35 degrees right there. Okay, so it's nice that they gave us a picture. So what we need to figure out is we need to figure this out, and we need to figure this out. Because how many more kilometers did they have to travel extra? Because this one would be longer. Okay, so let's do that. How can we do that? An angle right there. So we could figure that angle out. Okay, because now that will complete our pairing of side and angle. Okay, so let's do that. So theta is equals to 180 minus 21 minus 35. So that's going to give me 180 minus 21 minus 35, and it's going to give us 124 degrees. Okay, so that's 124 degrees. 124 degrees. Now that I have that 124 degrees, I have a complete pairing of angle and side, so we can figure that out. I can call this X, I can call this Y. It doesn't matter. You can call it A or B. Doesn't really matter. Okay, so 70 over sine of 124. Okay, let's calculate the X first. So the X, the side, sine of 35 degrees. And then we've seen this a few times now. Now that it's set up, we're solving for X, so we're going to cross multiply that. So it's 70 times sine of 35 divided by sine of 124 equals to X. Okay, so this one's just a matter of typing that in. So let's go ahead and type that in. And I get 48.43. 48.43, and the sides are measured in kilometers. We don't have to do anything. We don't have to do any square root because this is just the X. Okay, so that's the X. We don't have to do anything else. Okay, so now that one is 48.43 kilometers. Okay, now let's go ahead and calculate that side there. So this one, we still have a complete pairing of side and angle. These two, okay, got an angle, but missing side, so we can use sine law. Let's go ahead and do sine law again. But this time we're going to do the y, so y is equals to sine divided by sine 21. And again, cross multiply, so 70 sine of 21 over sine of 124 is equals to y. And the y is now isolated, it's alone. So let's go ahead and just figure this out. And I got 30.2, I would say 26 because it's need to be rounded up. Okay, so I got that one for 30.26. Okay. So as you can see, because of the detour, the plane, right, the plane there had to go this way up 48.43 and then down 30.26. So it actually traveled a little bit more than what it should be. So the question is, how much more did they travel? So that's going to be, they traveled that much, right? 48.43 plus 30.26. Okay. And if I subtract 70 from that, it's getting almost together. So I'm going to put a line there. So this is how much more, this is how, those two. And if I take away 70, then that's going to give me the leftover, or the extra time, extra distance that they traveled. Okay, so the extra travel of 8.69 kilometers. Okay. Okay, so there we go. That's that. So that one's okay. As you can see, it seems like we have to solve for all of the missing parts, right? And more. So that's a great question. Take a look at question number 4. Mary is hiking across a large field from marker A to marker B, which is 4 kilometers apart. Okay, so marker A to marker B is 4 kilometers apart. Okay, so I'm just going to put that there. After walking 2.8 kilometers, she realized she walked to point C. Okay, so after walking 2.8 kilometers, she realized that she walked to point C. So instead of going this way, she actually went this way, 2.8 kilometers. Okay, which is 6 degrees away from her original path. So which is 6 degrees from original path. So she went in a slightly wrong direction. Okay, slightly wrong direction. To the nearest tenth of a kilometer, how far from marker B is she when she realized her error? So she's like, after walking 2.8 kilometers, she's over here. How far is she to get to that part? So that's what we're trying to figure out. That's what we're trying to figure out. So now, what do I see? We don't have a complete ratio, but I can see a sandwich in here because the given angle is sandwiched between the two given sides, and I'm solving for this side. Okay, so this one calls for a cosine law. Cosine law. So let's get cosine law. So in terms of cosine law, okay, this is already a, b, and c, so I might as well just use that. So a squared is equals to b squared, so 2.8 squared plus 4 squared minus 2 times 2.8 times 4 times cosine of 6 degrees. Okay, so now that one is just basically a matter of typing that onto our calculator. Okay, make sure we press equals at the end only. Okay, not in between. Just type everything in and press equal at the end. I got 1.562709. Okay, now that's not really my answer yet. I have to do one more step because this is a squared. What we need to do is just the a. So how can we get rid of the squaring? So to get rid of the square, we have to take the square root. So once I take the square root, I'm just left with a. Okay, so no more square, so just a. So now I'm going to take a square root of that. And then my answer is 1.25. 1.25. And what's my unit? And 1.25 kilometers. Okay, so that's that one. So that one's not so bad. It's only one step, but we had to. The thing about this one is we have to read the question and then put in the information that we got. Once we have information here, we figured out, okay, what strategy am I going to use? Oh, I see a sandwich. The angle is sandwiched between two sides. So that's how and then we go on from there. Okay. So in this particular case, what we need to do is show our work, show the steps in between, and then show our final answer at the end with, oh, they said tenth of a kilometer. Okay, so if we do the tenth of a kilometer, it's going to be 1.3 kilometers. Okay, and then write down our answer with the unit at the end. Okay, so that's that. Let's take a look at number 5. Okay, we're going to finish this one here for sure. Number 5. Oops. There we go. So number 5 says a landscaper is putting up fencing around vegetable garden. The garden is triangular, okay, with two sides of 4.2 and 3.4 meters. The landscaper installs a fencing on these two sides so that the angle between them is 48. How much fencing will be needed? So again, this one here, we have to read our question. Okay, so they're trying to describe it. It's a triangular garden. Okay, well, triangular garden. Let's draw a triangle, whatever. Okay, triangle. That's my triangle garden. It says here a triangular garden with two sides of 4.2 and 3.4. Okay, well, we can just pick any. I can just say, hey, this is my 4.2, and then I call 3.4. It doesn't really matter. Okay, because we don't have a specific vertices there, so just say, okay, these are my two sides. And it says here, a landscaper installs a fencing on these two sides so that the angle between them is 48 degrees. So angle between these two sides is 48 degrees. Okay, there you go. Now you're probably thinking, oh, what else do we need to do? How much fencing will he need to buy to fence the entire garden? So how much fencing does he need? So he knows that this is 4.2 meters. He knows that this is 3.4 meters. So that's how much the fence you need for that side. We don't know what that is. So how much fencing do I need for this one? Okay, so I can see there's a sandwich again. Okay, the given angle is sandwiched sitting in between the two given sides. So we're looking for this side here. We can call it A, okay, or we can call it X. It doesn't matter. So I call it A. A is equals to this, the sum of the squares of these two. So 4.2 square plus 3.4 square minus 2 times same sides, 4.2 times 3.4 times cosine of 48. Okay, 48 degrees. Okay, we don't have to. Okay, so we can just, this is similar to the questions prior. We just type everything in the way we see them. This is times, right? Times, and that's square up there. And then we cos of 48, and then we press equal sign after we finish everything. So let's do that. So 4.2 squared. Okay, I get 10.08962. Okay, I'm just writing all of the decimals there. I'm not rounding it off because it's not my final answer. And then finally, the next thing we're going to do is get rid of the square. And how do we get rid of the square? We're going to take the square root. We're going to take the square root on both sides. So a is equals to whatever the square root of that is. So let's go ahead and type that in. This is going to be 3.118 meters. Okay. So we're just going to round it off to 2 decimal places. So we know that this is going to be 3.18 meters. Okay. So how much fencing did we answer the question? How much fencing will he need to buy to fence the entire, that means the whole garden. So total fencing would be 4.2 plus 3.4 plus 3.18. So 4.2 plus 3.4 plus 3.18 equals to 10.78, and that would be given in meters. Total fencing, 10.78 meters. Okay, so we're on that's question 5. We're on number 6. Final question in this one. Sun Li likes to make and sell triangular earrings at the summer craft. She designed an earring that has sides 2.1, 3.2, and 2.8. Okay, so interesting because it's a triangle. So they're just telling us the sides. So it's 2.1, 3.2, 2.8. Doesn't matter. Okay, so that's those 3 sides. She figures to put a hole for the clasp at the vertex of the opposite of the longest side. Okay, here. So this is the longest side. So she's gonna put a clasp. She's gonna put a clasp in here. Okay, opposite. So opposite to the longest side. So this is the one that we're looking for. That angle right there. Okay. So what will be the measurement of that angle? I see that we have 3 given sides. Okay, 3 given sides. So that calls for a cosine law. So cos theta. Okay. So if it makes it easier for you, you can call it angle A. Okay, so if you want, you can call it angle A. Makes it easier to see which side is which. So if this is angle A, then that means this is side A. Okay, so going to our equation, we want to make sure that we end with the side A at the end. Okay, so it's 2.1 squared plus 2.8 squared minus 3.2 squared. Okay, so this is angle A, and then this one would be the side A. And then divided by 2 times 2.1 times 2.8. Okay, it's going to be always 2 times these 2. Okay, so now I'm going to put the brackets at the front and the end of the numerator. And I'm also going to put the bracket in the front and in the end of the denominator so I can type everything at once. So cos of A is equals to whatever that is. Okay, so let's go ahead and type it in. Okay, so I'm going to get a decimal 0.170918367. Okay, Now this is not the angle. This is the cos of the angle. Cos of the angle. The next step that we're going to do is to get rid of the cos. So how do we get rid of the cos? The only way we can get rid of the cos is if we take the cos inverse, because cos inverse and cos, they cancel each other out. Cancel each other out. So we're left with just the A, angle A, angle A. And if I take the cos inverse of that, I have to do it on the other side, cos inverse on the other side. So let's do that. Cos inverse, answer. We're gonna get 80.16 degrees. There you go. Um, there we go. So we've completed all of the, well, not all, but the vast majority of the questions on the extra practice for sine law and cosine law. And actually, it has cosine law and sine law for and rule 180 for this one. Okay, so if there's anything else in here that you want me to go over, please let me know through email. Send me an email, and then I will try to either um, include that particular question on the blog, okay, or the YouTube streaming. Um, so I just want to remind everybody that our test on trigonometry is going to be on Thursday. So today is Tuesday, so tomorrow we have one more day to kind of um, organize all of our notes, organize all of our thoughts, and um, do review, final review, and then our test is on Thursday. Okay, so there you have it. I'm gonna post this one also on the blog. So if you didn't catch all of the things that I wrote on this page, I will have it all ready for you in a few minutes. Okay, so just hang in there. So with me, um, and so we are almost done with this particular unit. I want to remind everybody that our classes, including our live streaming, will be done by June 12th. So we're super close to getting things done at the end of the end of the course, and I'm sure you are super excited too that you're gonna get this done and completed in just a few more weeks. Okay, so I'll leave that with you for now, and thank you very much for watching. I will talk to you tomorrow. Okay, have a great day learning. Okay, bye for now.